Today, I'd like to talk to you about our capstone design project, Virtual Reality Training Module for Semi-Automated Bioreactor. In today's biotechnology industry, there are a variety of emerging challenges in biological production, from gene therapeutic manufacturing, vaccine throughput, viral vector scale-up, and many more emerging biopharma solutions. One of the most significant barriers in the field lay in research and development costs. However, new solutions are being introduced today, namely solutions that include disposable bioreactors, automated systems, and reorienting R&D manpower to use those new tools. Many pharma companies are introducing virtual reality training in order to train their researchers on these new tools at a much lower cost. VR training not only allows companies to retrain current scientists, but also allows some companies to introduce technical operators to supplement the need for more advanced researchers. Our client, Boehringer Ingelheim, was in need of one such VR program for their automated bioreactor system. In our capstone design project, we examined the usage of the Sartorius Amber 250 semi-automated bioreactor system and developed their own VR training program. In conjunction, we examined the applications of these systems in terms of scale-down studies and the overall cost benefits for the biotech industry. To produce an enhanced reality training program, we first need to familiarize ourselves with training on the system, and then implement that training into VR. The scope of our training program remained within the setup of the bioreactors themselves. Due to the automated nature of the bioreactor, the setup is the aspect that has the most potential for human error, which is why it's the main focus of the program. To do this, we first needed a thorough understanding of the steps involved for setup, which we became familiar with via visits to Boehringer Ingelheim's Athens campus. We then compiled all the steps required, which you can see here, from video and notebook evidence for our implementation into our VR program. We began our program by first modeling our bioreactor environment in Blender using pictures we obtained on site. Blender is a 3D modeling program that we chose due to its inherent compatibility with the chosen graphics engine called Unreal Engine 4. This engine would then be implemented into our Oculus Rift VR headset. This engine and this device are commonly used in entertainment and other training programs for interactive simulations. We also chose this engine due to its proven VR applicability and ability to both blueprint script and source edit code. The VR program allows the user to view and interact with the Amber 250 system in a virtual environment. The user will view text instructions to set up the Amber system within its space. The program lets the user interact with the Amber without needing to step foot on Boehringer Ingelheim's campus. This virtual experience is meant to replicate the setup of the bioreactor that would otherwise take time and money to operate. Rather than halt operation of the Amber 250, a user can learn the most vital steps without the possibility of the Amber breaking or being contaminated. The coding works by having a blueprint of instructions and commands as shown. When one set of instructions is performed correctly, the next set appears on screen. The red circle around the 2 blocks of code indicates the step that the user is currently on and the time this command should remain on screen. Our project successfully provides a resource for Boehringer Ingelheim that trains users on the setup of the Amber 250 through virtual reality. This training program is meant to save Boehringer Ingelheim time and money when training new users on this automated bioreactor. Thank you for watching.